Hello everyone, I am Prabhu Reddy. I am from Sri Venkateswara College of Engineering, Department of Basic Science. Today's subject is Basic Electronics. The subject code is BBEE203. Today the topics which we are going to cover are what is a diode or some points on diode and some characteristics of a PN junction diode. So let's start with the topic. Now let's see what is a diode. The term diode refers to two electrode or two terminal. That is, there is a positive terminal and a negative terminal of a diode also. It is basically an electrical device with two terminals or two electrodes. It is a semiconductor device. A semiconductor diode is simply a PN junction with a connecting lead on each side. Also, the diode is a one-way device. It offers low resistance when it is in forward biased, and it behaves almost as an open switch when it is in reverse biased condition. Approximately constant voltage drops occur during forward biased, and this condition simplifies diode circuit analysis. There are also some low current devices for using in switching circuits. High current diodes are most often used as rectifiers for converting alternating current to direct current, that is AC to DC conversion. And Zener diodes, which is also an example of diode, operates in reverse breakdown because they have stable breakdown voltage. Now let's start with the main topic of this session, that is PN junction diode. A PN junction diode normally permits flow of the electric current when it is in forward biased because it offers low resistance when in forward biased, but in reverse biased condition it offers very high resistance which blocks the flow of current. It can also be used as switch on when it is in forward biased. That is, in forward biased condition, the circuit of PN junction diode acts as a closed circuit and permits the flow of current. But when it is in reverse bias, the PN junction diode acts as a open switch. That is, the circuit is open and there is no possibility of flow of current. Also, PN junction diode provided with copper wire connecting lets become an electronic device known as diode. The circuit symbol or graphic symbol will be shown in the next slide. The arrowhead that is in the diagram indicates the conventional direction of current flow. These points will be observed in the next slide where the symbolic representation of a diode is done. Let's move on to the next slide. This is the symbolic representation of a PN junction diode. The arrowhead with a straight bar is basically the PN junction symbol. This arrowhead is the P type, and the straight bar connected to it is the N type. Uh, when P type is connected to a positive terminal and N type connected to a negative terminal, it acts in forward bias. But when the P type the end of the diode is connected to a negative terminal and N type end is connected to the positive terminal, it acts in reverse bias. The flow of current direction is shown using the conventional symbols. Now let's see the diodes which vary on the amount of how much current or voltage they can handle. They are classified into three types: low current diode, medium current diode and high current diodes, which you can observe on the right side of the slide. A PN junction diode can be destroyed if a high level of current overheats the device. It can also be destroyed if a large reverse voltage causes the junction to break down. Small diodes are limited to low current levels and low reverse voltages. Since the body of a low current diode is smaller, that is 0.3 centimeters long, the cathode is usually identified by a colored band. You can observe a black band on the low current diode. It is on the left end of the diode, which is identified as cathode. Uh, this type of diode are usually capable of handling a maximum forward current of approx 100 milliamperes. They can also survive about 75 volts reverse bias without breaking down, and its reverse current is usually less than 1 microampere at 25 degrees Celsius. Now let's see the characteristics of medium current diode and high current diodes. Medium current diode can usually pass a forward current of about 400 milliamperes and survive over 200 volts reverse bias. The anode and cathode symbols may be indicated by a diode symbol on the side of device. Usually low current and medium current diodes are mounted by soldering the connected LEDs to terminals. Power dissipation in the device is then carried away by air convection and by heat conduction along the connecting LEDs. High current diodes, also known as power diodes, generate a lot of heat, so air convention would be completely inadequate. Such diodes are designed to be connected mechanically to a metal heat sink. Power diodes can pass forward currents of many amperes and can also survive several hundred volts of reverse bias. It is basically connected to a metal sink to avoid the overheating of the diode. The metal heat sink actually it maintains or regulates the heat levels of diode. Thank you everyone for watching this video. I hope this might be knowledgeable to you. For more interesting topics and videos, please like and share the video and please subscribe to my channel. Thank you once again.